2020 Pascal Contest for Grade 9, Part 10. A big difference, counting or calculating. Hi, this is Lenny Wu. In Part 5 of this course, we mentioned that do not count if you can calculate. Now let's drive the concept home by seeing another example and see the big difference in terms of time saving using each method. Question 16. In the year 1997. In the diagram, all triangles are equilateral. What fraction of the triangle ABC is colored black? So this question type is shaded areas, as we can notice from shaded area questions in the Pascal Contest math questions. One way to solve this question is the usual way to count how many black shaded triangles are there within this huge big triangle. So the number of black triangles we can count in this small triangles, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So altogether we have 9 times 3 in 3 areas. We do not need to count all of them, but if you do want, feel free. And then we need to count the small triangle spaces, like this, like that, like this. So within one small, one medium triangles, we have how many black triangles? We have 9 plus how many white triangles? We have 1, 2, 3, 4, 5, 6, 7. We have 7. So altogether, let's times 3 plus in the middle ones, we have our big white triangles. That amounts to 9 plus 7, because that's equivalent to 9 shaded or black triangles plus the 7 white triangles. So the answer is 9 times 3 equals 27 over 9 plus 7 equals 16. We have 3 times 16 plus another 16, so that's 16 times 4. So the answer is 27 over 64. The answer is E. Well, after all these counting and calculation, although we divided into 4 groups in order to count, that's still a lot of counting, and it's very easy to make mistakes. And also it takes more time. So the question is, can we do it quicker? Yes. As we talked about in previous parts, do not count when you can calculate. Okay, first, before we calculate, let's define some shapes. Let's say the first bigger triangle, let's call it triangle 1. Now, the second triangle size, which is 1/4 of the bigger one, let's call it triangle 2. Even 1/4, triangle 3. Last one, triangle 4. All right, so let's calculate the colored black triangles in this bigger one, triangle 1. So in the big triangle 1, we can divide it into 4 equal-sized equilateral triangle. So let's assume the top ones are shaded. The middle one is white. So what is the area of shaded or colored black? That's 3 out of 4 triangles. And by this time you can see, no, the top triangle 2, it's not all shaded. It's only partially shaded. That's fine. Now let's further divide this triangle into 4. Type triangle 3s. So the top ones, bottom left, bottom right, are shaded. So that's another 3/4 shaded. And by this time you can also say, no, the top triangle number 3 is not all shaded. It does have the top portion, bottom left portion, and bottom right portion shaded. The middle one is still white. Not a problem. So that's also 3/4 shaded. By this time, we have found out the overall area which are shaded. Now let's time these together. 3 times 3 times 3 gives you 27. 4 times 4 times 4, that's 4 to the power of 3. That's 27 over 64. Still gives you answer E. But through calculating, how long does it take us to get the final answer? Possibly less than half a minute or 30 seconds. But the first method, counting, especially as recommended in solutions, it takes more than 1 minute. Okay, from this question we learn how to probe the question first before we jump right into answering the question. And also, do not count when you can calculate. That can save you tons of time, which are crucial in taking Pascal math contest. Okay, that's all for this session. See you in the next part.